We're on a new chapter. This time we're going to talk about some probability theory and some counting methods. Some really fun stuff. Just pretend you're playing around. I think you'll like this. First of all, on this first section, we'll talk about the fundamental counting principle. Now, what does that mean? Well, one thing it means is that instead of counting a number of possibilities, 1, 2, 3, 4, and so on, till we finally get all of them, if we've got a list of them, there's another way. As long as we know how many of each of the choices we've got, we can figure out how many different ways you can do something. So let's take a look at this. We're going to find out how many possible outcomes in a given situation. So here's the whole thing really in slide 3. If you can choose something from a group of m items and a group of n items, then the way you can make 2 choices from those groups is m times n. Well, let's make this a little bit more concrete. Let's suppose we've got m of these items. We'll get to more examples later. And let's suppose we've got 7 of those. Then if we're picking one of those and then one of those, we've got 5 times 7, or 35 ways we can make those 2 selections. So let's take a look here. Sometimes we can make a tree to represent the possible choices. So here you are. First of all, you're picking from 2 pairs of slacks. Once you've decided which of those pairs you're going to wear a top. And with each of those pairs of pants, you could choose this top, or this top, or this top. If you chose these slacks, then same 3 choices. 2 times 3, 6, oops, shouldn't say choices, you might think of that, 6 outfits. 6 outfits that you could wear. So if you only had 2 pairs of slacks, 3 shirts, you could wear 6 different outfits. In other words, you could wear a different outfit from Monday through Saturday, or Sunday through Friday. Let's take a look at a more palatable solution. Let's suppose we go to this restaurant, and it's a small restaurant. It's got 6 appetizers, but 14 main courses. How many times can you go there and get a different meal? So you're going to choose one of those and then one of the main courses. All you need to do is multiply 6 times 14, and the number of 2-course meals is 84. Just multiply those 2 together. So all you need to do is multiply the number of ways in which each thing, multiply, number of ways each item or each thing can occur. Remember the 2 pairs of jeans and 3 t-shirts, 2 pairs of slacks, or 2 pairs of sneakers, excuse me. If it's more than 2 things you're choosing, it's the same deal. Take the jeans, we've got 2 jeans, then we'll pick from one of the 3 t-shirts, and then we'll pick one of our 2 pairs of sneakers. And what do we have? Well, just multiply that 2 times the 3 times the 2. There's a tree diagram we could use, choosing the slacks, either this one or this one. Then choose one of the shirts, and then finally one of the two pairs of sneakers. 12 different ways you can make an outfit with 2 pairs of slacks, 3 t-shirts, and 2 pairs of shoes. Not a whole lot in our wardrobe, but we can go to 12 different events and have a different outfit. Let's take a different look. This time, this is really a perfect time for this too, because we are, or you are, choosing what you're going to take next semester. So you're supposed to take a math, an English, and the humanities course. And for the math, there are 8 possible sections you could pick. 5 English, 4 humanities. How many ways can you put a schedule together, assuming there are no conflicts at all? So the 8 times a 5 times a 4. You've got 3 groups, so you need to have the number of items in each group, multiply those numbers together, and you can have 160 different ways of creating a 3-course schedule for next semester. How about you taking a multiple choice test? It has 10 questions. Every question has 4 answer choices. You might think of as A, B, C, and D. You're not going to leave anything blank. You're going to make one of those 4 choices for each of the 10 questions. How can you answer the questions? Well, question number 1, 4 choices. Question number 2, 4 choices. 3, 4. Each one of those 4 choices. Multiply those numbers together like this, and gee, I bet you never expected that. Just 10 questions, 4 possible answers in each one, and there are over 1 million different ways you could answer that test if you're just throwing answers out at random. Oh, by the way, that's not a good idea in taking even a multiple choice test. Let's look at another one. Give you a different angle on it. Telephone numbers in the United States. Now, we know that there are 7-digit local telephone numbers, and you've got some area codes, 3-digit area codes. How many different phone numbers can you have in the United States with that setup? Well, we've got 10 groups of items. We've got 3 groups for the area code, 7 groups for the local telephone numbers. So there are choices. Area code, 8 times 10 times 10. Remember, for the area code, you can't use a 0 at the beginning, and you can't use a 1 at the beginning. But for the second and third digits, any of the digits are fine. So just for the area codes, if this question were about how many area codes could you have? Well, 8 times 10 times 10. 800 area codes. However, we're talking about all the telephone numbers that are possible. Again, the local telephone number, the first one can't be a 0, can't be a 1. Those are out. At least 8 possible digits for the first digit in the 7-digit local telephone number. 8 for the first, then 10, 10, 10, 10, 10 possibilities for each one. Multiply all that together. Don't forget the area code. So the total number of different telephone numbers we can have here in the United States are, you have the answer? Over 8 billion numbers. Almost 6, oops, did I say 8? I meant 6, almost 6.5 billion possible telephone numbers in the United States. Well, folks, that's it for section 1. I hope you enjoyed the travel. It's pretty simple, and I think it's sort of fun, especially putting those meals together or the telephone numbers together, zip codes, all kinds of things. It can be a fun thing. Anyway, that's it for section 1. Hope you enjoyed the trip. See you next time in section 2. Bye for now.